All right, so in this video, I'm going to talk about domain restriction. And if you take a look at this function right here, right, fx equal x squared, and if I ask you, is this function one-to-one? And clearly you can see that it's not, right? It does not pass the horizontal line test, therefore it does not have an inverse. But it doesn't mean you can't restrict the domain, right? You saw a little bit of that in the previous example. And what is true in general about functions that pass the HLT? Well, what's true is that any function that passes the HLT strictly increases, okay, on the entire domain, okay? If f is strictly, just means entirely, okay? F is strictly increasing on its entire domain. Then we know that the function, so, what does it mean f is strictly increasing? Let's say I give you something like this, right? Notice the function is increasing on its entire domain, right? It's clearly going to pass the HLT. Or, likewise, if f is strictly decreasing on its entire domain. Right? I mean, think of something that's strictly decreasing, like maybe a line that goes like this, right? Clearly decreasing from minus infinity to infinity. This will pass the HLT. So how does that relate to this? Well, this parabola right here, right? It decreases going from left to right until it hits 0, and then increases, right, from 0 to infinity to the right of 0. And so, right, if we restrict the domain at its vertex, right? Let's say we said, hey, x is less than or equal to 0. Then you would graph something like this, right? Clearly, the function itself is decreasing on its entire domain, right? For x is less than or equal to 0, minus infinity to 0, it's decreasing. It's going to pass the HLT, and hence it will have an inverse, okay? So the key, right, is to restrict the domain. Typically, you're going to get a parabola or an absolute value right at the vertex, right? Because once you chop it off, right, you can tell that it's either strictly decreasing or strictly increasing, and you have a choice, as you will see in this next example. Okay, so let's take a look at example 2. It says restrict the domain, so the function is one-to-one. Find the inverse, and state the domain range of f and f inverse. Okay, so right now, right, if I ask you, hey, just plot this for me, you should be able to have a rough idea how to sketch it without drawing a ton of tick marks, right? This is your absolute value function shifted 2 units to the right, okay, V-shaped graph. Now, just like in the previous example, right, I restricted the domain at the vertex. Well, if I ask you, what is the vertex right here, you would say the vertex is 2, 0, right? And why don't we restrict the domain of f? And you have a choice, okay? So depending on how you want to restrict it, if you want to say x is less than or equal to 2 or x is greater than or equal to 2, your answer might be different, but it's still correct, okay? So I'm just going to say for x is greater than or equal to 2. All right, so I'm going to restrict it there. And notice on part C, it says state the domain range of f and f inverse. So to finish this problem, the range, right, is y is equal to 0. Now, once you have the domain and range of f, you have the domain and range of f inverse, right? Because they interchange. So if the domain of f is x is greater than or equal to 2, that means the range of f inverse is y is greater than or equal to 2. If the range of f is y is greater than or equal to 0, that means the domain of f inverse is x is greater than or equal to 0. Okay, so we answered part C. We answered part A, right, because we restricted the domain, x is greater than or equal to 2. And then last but not least, we need to find the inverse, right, for part B. How do we actually find it? Well, if I switch my variables, right, I need to get y by itself. Now, remember, absolute value always throws students off, right? To drop the absolute value symbol, you have to say y minus 2 is equal to positive x, right? Or, right, y minus 2 is equal to negative x. And you get y by itself on this equation, you're going to get y is equal to x plus 2. On this equation, you're going to get negative x plus 2 is equal to y. Now, at this point in time, right, you have a choice of deciding, which one of these equations do I want to use, right? And the way you determine that, right, is you take a look at your domain right here. The domain of my original function is x is greater than equal to 2, which means the range, right, of my f inverse is y is greater than equal to 2. And so if y is greater than equal to 2, right, between these two guys right here, right, I'm going to pick this equation, right, because this is going to make my y bigger than or equal to 2, okay, assuming that x is greater than or equal to 2. All right, so this is my f inverse. That's x plus 2. And you can verify this, right? How do I verify this? On the graph, right? Remember, my absolute value function got restricted, right? This is f, and the domain is x is greater than or equal to 2, right? Clearly, this is my f function. And then this guy right here, right, is x plus 2. That's just the line x plus 2, which is somewhere over here. The y-intercept's 2. It's going to look something like this, right? Both of these graphs look like they are the reflection over the line y is equal to x. Okay, if you pick the other one, right, it's not going to look like a reflection of the line y equals x. But the way I know to pick this one is because the domain is x greater than or equal to 2, therefore y is greater than or equal to 2, which means that this one right here will give the